Welcome, curious minds, to another deep dive.
Great to be here.
Today, we're plunging into one of Earth's last truly unexplored frontiers, Antarctica.
An incredible place.
Imagine somewhere so remote, so untouched, that it still holds secrets. Secrets challenging our very understanding of history, maybe even geology.
Hmm?
What if, hidden beneath miles of ice, there were structures? Well, structures that defied all explanation.
Ah, the big question.
Exactly. We're talking about whispers, rumors, sensational headlines about pyramids in Antarctica.
Right. The internet loves that one.
It sounds like something straight out of a blockbuster movie, doesn't it? A real sci-fi plot.
It really does capture the imagination.
But we're here to go beyond those, wild theories and explore what our sources actually tell us.
And that distinction is absolutely crucial. When you're dealing with environments as extreme and, frankly, pristine as Antarctica, the line between a natural formation and something artificial, well, it can look pretty blurred if you don't know what you're looking at.
Right to the untrained eye.
Precisely. Our goal in science is always to seek the empirical evidence first. Understand the complex geological processes, the physics at play, before jumping to conclusions.
Makes sense.
And honestly, the depth of scientific inquiry that goes into understanding these hidden environments is, for my money, far more fascinating than any conspiracy theory.
I couldn't agree more. And that's really our mission today. We've pulled together a stack of incredible sources, groundbreaking scientific reports, detailed geological analyses.
Some really solid stuff.
Yeah, and we're going to take you on a journey through them. Our goal: separate the verifiable facts from the, let's say, fantastical fiction regarding these mysterious Antarctic discoveries.
Sifting through the noise.
Exactly. And what you'll find is that the true scientific realities, they're often far more mind-bending, more incredible than anything conjured up by the wildest imagination. Okay, let's unpack this.
Let's do it.
So let's kick things off with some of the most viral, intriguing claims, the ones that have really captured the internet's imagination, drawing millions of views, endless speculation.
Oh, yes. First up, this mysterious door in the ice. You might have seen the satellite images doing the rounds.
I think I know the one you mean. Very rectangular looking.
That's the one. Fueling all sorts of outlandish theories. Maybe it's Bigfoot's secret holiday home.
Unlikely.
Or a hidden hangar for a Star Trek shuttle. Or even, for the really imaginative folks, a gateway to Agartha, that mythical kingdom supposedly hidden inside the Earth.
Right, the Holly Earth idea.
It certainly looks otherworldly, doesn't it? With that seemingly perfect rectangular outline against the ice.
It does. Those images are striking, definitely ignite the imagination. But scientifically speaking, these claims have been pretty thoroughly debunked.
Okay, so what is it then?
Well, what looks like a secret door is actually located in an area of what scientists call fast sea ice.
Fast sea ice?
Yeah, it's a specific type of ice. It forms and then stays attached to the coastline. This particular area has lots of small islands nearby, relatively shallow water.
And the key to understanding why it looks like that lies in how this ice interacts with the geology underneath it.
Ah, the hidden stuff.
Exactly. When you have these immense forces of ice flowing around hard, often jagged rocks hidden just below the surface, it can create patterns that, look unusual, but are entirely normal for these conditions.
So the rock shapes the ice flow.
Precisely. And in this specific spot, the ice is relatively thin. That means the rocks underneath have a really significant influence on its movement and shape, almost molding it. Plus, you've got the Antarctic winds.
Which are famously strong.
Incredibly strong and cold. They play a major role today, constantly shaping and sculpting the snow and ice into all sorts of forms. You get sharp edges, deceptive shadows. It's like natural ice sculpture.
So this door, it's just natural sculpture.
Pretty much. This particular formation is really a testament to the powerful, yet entirely natural artistry of these elements. Wind, ice, rock, interacting over time.
So you're telling me, despite all the whispers of ancient civilizations or, ET bases,
Right.
The reality is far simpler. Maybe less exciting for some, but still pretty cool geologically speaking. It's not a crafted entryway, but a carved landscape.
That's exactly it. What you're looking at is essentially a rocky ridge,
Yeah.
a natural outcrop that's become slightly exposed as the surrounding fast ice melts and shifts.
Okay, I can picture that.
The peak of this supposed door,
Yeah.
that's just the exposed top of the rock. And the sides, nothing more than snow traces, etched and sculpted over time by those relentless winds, often blowing consistently in one direction.
Wow.
So, yeah, in essence, natural rock formation, partly revealed by melting ice shaped by extreme weather. Nature's artistry is truly astonishing. Sometimes it mimics structures our human brains are just, well, hardwired to recognize.
He's seeing faces in clouds.
Exactly. That phenomenon where our minds perceive familiar patterns in random or ambiguous stimuli. It's called periodal.
Pareidolia, right.
That's why we see faces in clouds, or the man in the moon, or in this case, a doorway in the ice. It's a powerful demonstration of how our perception works, not evidence of hidden secrets.
Fascinating how our brains do that, seeking patterns everywhere. And speaking of viral sensations playing on that tendency, another one that did the rounds was the ice ship anomaly.
Oh, I remember that one too.
Imagine finding this 122-meter-long ice formation, almost 240 kilometers offshore in the Southern Ocean, and it looks eerily like a massive frozen ship.
Yeah, the resemblance was uncanny in some photos.
The internet, as you can imagine, went absolutely wild. Theories ranged from, like, a futuristic vessel lost at sea to a derelict ship that somehow drifted all the way from the Bermuda Triangle,
Good grief.
ending up perfectly preserved in the Antarctic deep freeze.
The initial visual was certainly compelling, almost too perfect, you know?
Yeah.
And for a short while, it definitely captivated a lot of people.
Understandably.
However, once again, scientific scrutiny quickly brought clarity. There was absolutely zero scientific evidence, no radar signature suggesting metal, no visible structure, nothing to suggest it was an actual man-made vessel.
It's just ice.
Just a remarkably large and unusually shaped piece of ice, an iceberg, basically. Probably calved off a glacier, then eroded by wind and waves until it attained that ship-like silhouette.
Okay, makes sense. But how did they prove it definitively?
Well, the undeniable proof came pretty simply. Curious individuals, including some research teams and I think even some adventurous tourists, actually ventured out to investigate during the Antarctic summer.
Ah, summer. Melting season.
Exactly. As the temperatures rose, which they inevitably do, the ice started its natural melting process. And as it melted, the hypothetical ship, well, it quite literally disintegrated, disappeared within days.
Poof, gone.
Gone. Revealed it to be nothing more than a transient ice formation. It's a powerful reminder of how nature can sculpt these incredibly deceptive forms, but they're often fleeting.
Right. Nature sandcastles almost.
Nah.
Okay, and now for the big one. The claim that really gets people talking, the one that's been circulating for years. The Antarctic Pyramid.
Ah, yes. The pyramid.
I know. You're already picturing ancient Egyptian secret bases, lost civilizations, maybe aliens.
Holding my breath.
But hold these exciting theories for just a moment. Because the truth, while maybe less sensational for some, is rooted in the incredible power of geology.
Let's get straight to it on this one. What's widely shared online as the Antarctic Pyramid is simply a mountain.
Just a mountain. But it looks so pyramid-like.
It is very striking, a naturally occurring mountain, undoubtedly,
Yeah.
but a mountain nonetheless. It's formerly known as Mount Sipple, actually, a prominent peak within the Ellsworth Mountains.
Part of a larger range, then.
Oh yes, part of the highest mountain range in Antarctica, a colossal chain stretching over 320 kilometers across the continent. And interestingly, this isn't even the first time such a pyramid has been sort of identified there.
Really?
Decades ago, explorers from the British Antarctic expedition found another oddly shaped mountain and playfully nicknamed it the Pyramid, even though it didn't really look like a perfect pyramid either.
Huh, so it's a recurring thing.
It seems so. What we see today with Mount Sipple, one of the famous photos, is just another example of natural geological processes. Intense glacial sculpting, relentless erosion by wind and ice over millions of years.
Shaping the rock.
Exactly. These forces shape mountains into forms that can, from certain angles under specific lighting, create this striking visual confusion. It tricks the eye into seeing something artificial.
More pareidolia.
On a grand scale, it's a stunning example of how nature itself can carve monumental, deceptive forms.
So what does this all mean? It means even nature has a flair for the dramatic. It sculpts these awe-inspiring, deceptive forms that look almost too perfect to be natural, almost designed.
The universe, it seems, has its own grand architects, working with ice and wind over millennia. It's pretty spectacular when you think about it.
It really is. Okay, now that we've cleaned up some of those sensational but ultimately debunked myths,
Cleared the air a bit.
let's pivot to what's truly astonishing about Antarctica. Because while there might not be man-made pyramids or hidden doors, the continent is hiding wonders. Wonders that are far more captivating and scientifically significant.
Absolutely. The reality is often stranger and more interesting than fiction.
For instance, did you know there's a gigantic ice shelf that reminds researchers of the Grand Canyon? that scale. It's a perfect segue to what truly is fascinating and hidden beneath all that ice. A world utterly alien to us, yet right here on Earth.
It truly is. And building on that, one of the most astonishing scientific discoveries in recent times involves Antarctica's subglacial landscape underneath the ice sheet.
Okay, what did they find?
Researchers, using advanced tech like ice-penetrating radar and seismic surveys, they've actually uncovered a staggering 91 volcanic cones buried deep under the ice.
91. Volcanoes under the ice.
91 confirmed so far. And these aren't just small hills. Some are found as deep as 3 kilometers below the surface, and they rise to impressive heights over 900 meters.
That's huge, like a medium-sized mountain buried completely.
Exactly. The tallest is roughly comparable to Mount Washington in the U.S. This discovery makes the West Antarctic Rift System potentially the world's most extensive volcanic region, stretching across an area roughly the size of Europe.
Wow, and it looks so flat on top.
Deceptively flat. It fundamentally reshapes our understanding of Antarctica's geology, its activity, and even its long-term stability.
That's incredible, 91 volcanoes. And it ties into another kind of bizarre phenomenon researchers encountered while drilling boreholes deep into the ice.
Oh, what was that?
They would drop chunks of ice down the incredibly deep holes, maybe testing something, and they'd hear these strange, unusual sounds echoing back up.
Strange sounds.
Yeah, they describe them as sounding like a spaceship breaking through obstacles, or even cosmic whispers.
Okay, that sounds pretty eerie.
Right. Must have been quite unsettling, maybe intriguing, too.
It certainly sounds like it would be. But the science behind those strange noises, it's actually a perfect illustration of the natural world's often counterintuitive complexities.
Not spaceships, then.
Probably not spaceships, no. What they were likely hearing was a phenomenon known as the Doppler effect, in action.
The Doppler effect, like with a siren.
Exactly like with a siren. Or a car horn. It sounds higher pitched as it approaches you, it drops in pitch as it moves away, right?
Yeah.
It's the same principle. The Doppler effect explains how the frequency of a wave, sound, light, whatever, changes relative to an observer who's moving relative to the source.
Okay, so how does that apply to ice falling down a hole?
Well, as the ice blocks fell, maybe 140 meters down this borehole, they generated sound waves. As the blocks accelerated downwards, the sound waves they created were bouncing off the borehole walls and coming back up to the surface.
Right.
And because the source of the sound, the falling ice, was constantly changing speed, the frequency of those reflected sound waves changed too. That's what created those shifting cosmic noises.
Ah, I see. It's an acoustic illusion caused by the movement.
Precisely. A purely physical phenomena. Fascinating, but not supernatural.
That's a fantastic explanation. Makes it really clear. And speaking of boreholes, it brings us nicely to one of the most vital scientific endeavors in Antarctica, extracting ice core samples.
Oh, absolutely fundamental work.
These aren't just pretty tubes of ice, are they? They're literally a frozen history book of our planet, records dating back hundreds of thousands of years.
That's a perfect analogy. Antarctic ice is incredibly significant. It provides this unique, unparalleled archive of Earth's past. Ice cores, some drilled deep enough to reveal ice up to 800,000 years old. They're vital climate indicators.
Like tree rings, but for the whole planet.
You can compare them to tree rings, yeah, where each ring tells a story about conditions. But ice cores are far more complex, much more detailed. They give us an unparalleled record of Earth's ancient atmosphere, temperature, environmental conditions. It's all trapped in there.
So how do scientists actually get these ancient records out from miles of solid ice? It sounds incredibly challenging, not just grabbing a drill from the hardware store, I imagine.
Oh, definitely not. They use specialized, often custom-built drills. These create perfectly cylindrical holes, often incredibly deep. Some famous cores, like from Vostok Station or Epico Dome C, went down over 3 kilometers.
3 kilometers of ice.
Yeah, and from these deep boreholes, they extract the ice core samples. They're carefully segmented, cataloged right there on site. And these samples are extraordinary because they contain microscopic traces of everything from that time. Prehistoric dust.
Dust.
Yeah, tells you about wind patterns, aridity, teeny air bubbles, actual samples of ancient atmospheres trapped inside, ancient sea salt, even volcanic ash from past eruptions, all perfectly preserved, layer by frozen layer.
Like finding a prehistoric insect in amber, but it's the whole atmosphere.
Exactly, a true time capsule of our planet's past climate.
And once they have these precious, fragile samples back in the lab,
Yeah.
what happens then? I imagine contamination must be a huge worry. These things are ancient, pristine.
Contamination is, well, It's a critical concern. You could almost say it's an obsession for ice core scientists.
I bet.
In the laboratory, the analysis involves carefully crushing or dissolving these ice samples in incredibly sterile, ultra-clean conditions. They have to avoid any contamination from the modern environment, even from human breath.
Wow. So like clean rooms and space missions?
Very similar protocols. Scientists wear special protective suits, multiple layers of gloves. All equipment is constantly disinfected. Even a single fingerprint could potentially compromise a sample. Utmost care is taken.
So what can they learn from all this careful work?
So much. This meticulous process lets them extract and analyze those ancient air bubbles to determine past atmospheric CO2 and methane levels. They analyze the dust for wind patterns, volcanic events. They study water isotopes to figure out past temperatures.
That's incredible detail.
It is. And this data is invaluable because it directly reveals historical climate changes. It gives us direct evidence, for instance, that the West Antarctic ice sheet melted significantly in the past.
When was that?
Around 125,000 years ago, during a period when temperatures were warmer than pre-industrial times.
And that has implications for today.
Profound implications. It tells us about future sea levels, the potential impact on coastal cities worldwide. It shows this massive ice sheet is highly sensitive to even relatively small increases in global temperature. The insights from just one ice core can literally rewrite our understanding of climate history and future risks.
From the invisible mysteries hidden in ice cores, let's turn to something much more visually striking, almost otherworldly. The enigma of blood falls.
Ah, blood falls, a truly bizarre sight.
Right. This phenomenon was first spotted by the British geologist Thomas Griffith Taylor way back in 1911, a waterfall that looked like it was bleeding this vivid, shocking red color at the base of a glacier. The glacier is now named after him, Taylor Glacier.
And for decades, it was a complete scientific mystery, sparked all sorts of wild speculation.
I can imagine. So what is causing it? Not actually blood, presumably.
No, not blood. It was a true scientific puzzle for over a century. Early theories suggested things like red algae, but the water was found to be too cold, too salty for most algae. The solution only came much later, with the advent of really advanced technology, specifically powerful electron microscopes.
Ah, technology catches up.
Exactly. A team of American scientists actually ventured underneath the Taylor Glacier, sampling the water from this anoxic, meaning oxygen-free, hypersaline subglacial lake that feeds the falls.
Under the glacier, wow.
Yeah, pretty adventurous science. And what they discovered were these tiny, iron-rich nanospheres.
Nanospheres, like tiny balls.
Microscopic particles, yeah. A mere 1/100th the size of a human red blood cell. And they're derived from ancient microbes.
Microbes, living things.
Well, remnants of them. These microbes have been hidden within the ice depths, totally isolated from the sun and atmosphere for thousands, maybe even millions of years.
Incredible.
And these nanospheres are chemically interesting. Unlike many minerals that form rigid crystalline structures, these were amorphous to lakes. They lacked a defined internal structure.
Which made them hard to find.
Exactly why traditional geological analysis, which often looks for those predictable crystal patterns, completely missed them for so long. These nanospheres are filled with iron, along with silicon, calcium, aluminum, sodium.
Iron. That sounds key.
That's the key. It's this unique chemical composition, particularly the iron oxidizing, essentially rusting, the moment it hits the air outside the glacier, that gives the water its vivid blood red color.
Wow, so it's literally rusty water from ancient microbes. That sounds like something out of a science fiction novel. Prehistoric life, hidden for millennia in total darkness, extreme cold, literally bleeding from a glacier.
It really does.
What are the wider implications of finding life or evidence of it surviving in such an extreme, ancient place?
The profound implication is exactly that. The discovery of life, or its biosignatures, hidden and potentially thriving for thousands, even millions of years within the ice depths, completely cut off.
And that relates to space.
Directly. This isn't just a curiosity about Earth. It connects straight to the search for extraterrestrial life. Scientists have actually simulated a Mars rover landing near blood falls.
No way. Why?
To test its ability to detect these unique biosignatures in a cold, iron-rich environment. Because that's similar to conditions we think might exist or have existed beneath the Martian surface or on icy moons like Europa.
So if life can survive there, maybe it can survive elsewhere.
That's the thinking. If life can adapt and persist in such extreme, isolated, ancient conditions here on Earth, like a subglacial, hypersaline lake, what does that tell us about the potential for life in similar niches elsewhere in our solar system, or even beyond? It fundamentally redefines life's resilience and expands our understanding of where it might exist.
It really does. It raises that important question. What else could be hidden down there or out there, waiting to tell us its story?
Precisely. Not just on Earth, but maybe on other worlds, too.
That's a truly mind-blowing thought, expanding our horizons way beyond Antarctica. And if you think that's surprising, prepare yourself for this next one. Evidence suggests that about 90 million years ago,
Okay.
during the mid-Cretaceous period when dinosaurs were roaming other parts of the world, a rainforest existed near the South Pole.
A rainforest in Antarctica 90 million years ago.
Yep. Not exactly the icy tundra we picture today, is it? This completely flips our understanding of what Antarctica once was.
How on earth did they figure that out? Fossils. Sort of. This incredible discovery came from analyzing sediment cores drilled from the seabed off the coast of West Antarctica, specifically from the Wilkes Land Basin.
Drilling the seabed this time, not the ice.
Correct. In 2017, an international team drilled down, expecting to find just cold ocean sediments. Instead, about 30 meters beneath the seabed, they hit this layer of preserved mud.
And what was in the mud?
It was rich with plant pollen, spores, even fragments of flowering plants and roots. The cores revealed unmistakable traces of ancient willow wood, various insect parts, diverse fungi, even poppy fossils.
Poppies near the South Pole.
Can you believe it? It's direct proof that a lush, temperate, swampy rainforest environment once thrived incredibly close to the South Pole.
So what was the climate like then?
Astonishingly warm for that latitude. It means that what's now Earth's coldest, iciest continent was, at one point, a green, swampy landscape, teeming with life. Average annual temperatures were likely around 12 to 13 degrees Celsius.
Like Northern Europe today.
Roughly, yes. Which implies very, very high atmospheric CO2 levels back then. It completely reshapes our understanding of Earth's deep past climate cycles and shows the remarkable adaptability of life. It suggests a greenhouse Earth far warmer than models previously predicted for such high latitudes.
Amazing. Okay, from the ancient wonders hidden beneath the ice and sediment, let's shift gears now. Let's talk about the very real and immediate dynamics of Antarctica's ice, especially how it's changing now and the cutting-edge tech we're using to understand it.
A critical area of research today.
I'm talking about the RAN autonomous underwater vehicle, named after Ran, that Norse sea deity associated with the nets and the drowned. Fitting, maybe.
A powerful name for a powerful tool.
This isn't about ancient mysteries anymore. This is about our planet's future. RAN is a truly cutting-edge tool for exploring those deep, mysterious, and frankly dangerous waters beneath Antarctica's vast and increasingly vulnerable ice shelves.
RAN is an incredible piece of engineering. It's an autonomous submarine, about the size of a small car, packed with sophisticated sensors, sonar, cameras, instruments measuring water temperature, salinity, oxygen levels, everything.
And it goes where humans can't.
Exactly. Its groundbreaking mission back in 2019 under the Dotson ice shelf.
Whoa.
Well, that was revolutionary. Dotson is this colossal icy giant, 48 kilometers long, nearly the length of New York City.
Wow.
Scientists described getting data from under there as being like seeing the other side of the moon. It was an area previously completely inaccessible, unmapped, a dark, frigid realm beneath miles of ice.
So what did RAN do down there?
For 27 days, it tirelessly traveled nearly 1,000 kilometers beneath that thick ice, mapping the terrain. And it found this dynamic, incredibly uneven landscape, huge cracks, massive ridges, formations that look like frozen dunes.
Frozen dunes?
Yeah, and these bizarre, swirling, droplet-shaped patterns etched into the underside of the ice, almost like abstract artwork more than geology. Some nearly 400 meters long, unlike anything scientists had really seen before in that kind of environment.
And those swirling patterns you mentioned, like giant frozen scribbles, our sources say they're carved by warm water melting the ice from below. But why the swirling? Is there a specific reason for that distinct, almost artistic shape?
Yes, absolutely. Those swirling patterns are a fascinating manifestation of the Coriolis effect.
Ah, Coriolis, like with hurricanes and ocean currents.
Exactly the same principle. It's fundamental to fluid dynamics on a rotating planet. Imagine you're on a giant spinning carousel, trying to throw a ball straight towards the center it appears to curve relative to you.
Right, because the carousel's moving under it.
Precisely. The same thing happens with large-scale movements of water and air on rotating Earth. The warm ocean water flowing under the ice shelf gets deflected by Earth's rotation. That causes it to swirl and carve these distinctive spiral and droplet shapes into the ice from below.
And these patterns were huge.
Immense, some comparable to 3.5 football fields long. They indicate incredibly strong, persistent sub-ice currents must be present there. Scientists have since found similar patterns under other Antarctic ice shelves, though maybe not quite as pronounced as under Dotson, suggests specific conditions there really amplify the effect.
So RAN wasn't just churning pretty underwater ice sculptures. It was gathering critical data about the health, the stability of these huge ice shelves. And what it found under Dotson, that was particularly alarming, wasn't it? A direct look at ocean warming's impact.
It was indeed deeply concerning. The Dotson ice shelf isn't just a big floaty piece of ice. It acts as a crucial protective barrier, a sort of buttress for some massive West Antarctic glaciers lying behind it on land, including parts of the Thwaites Glacier system.
Thwaites, the Doomsday Glacier.
That's the one. These glaciers, held back by the ice shelf, contain enough ice to significantly raise global sea levels if they destabilize.
So the ice shelf holds them back.
Yes. But when warm ocean water gets underneath and melts the ice shelf from below, that's called basal melt, this protective barrier weakens. It's like taking away the brakes.
Allowing the glaciers to slide faster.
Much faster into the ocean. And that contributes significantly to global sea level rise. RAN identified these huge pockets beneath Dotson where ice was melting at an alarming rate, sometimes tens of meters per year, directly linked to these strong, warm, underwater currents eroding the ice.
Like seeing a wound on the glacier.
That's a good way to put it. It revealed a rapid and previously unseen vulnerability. The data immediately underscored how urgent it is to understand and monitor these sub-ice shelf environments.
That's a really stark picture. And unfortunately, the story of RAN itself, it doesn't end there, does it?
No, sadly not.
Early in 2024, during a follow-up mission, this time to the Thwaites Glacier itself, the Doomsday Glacier, because its potential collapse alone could raise global sea levels by over half a meter.
A catastrophic scenario.
RAN simply vanished. Gone. It just highlights the immense challenges, the risks involved in this vital research.
The loss of RAN was a significant, really tragic blow to the scientific community, especially the team at the University of Gothenburg who operated. Its mission was just paramount.
What was it trying to do at Thwaites specifically?
It was trying to map the underside of Thwaites, particularly its grounding line, that critical point where the ice lifts off the seafloor and starts floating, an area never explored in such detail before.
Why is that grounding line so important?
Because understanding how it's melting and retreating is critical to predicting the glacier's overall stability and melt rate. Thwaites is one of the most critical, fastest melting glaciers on the planet. RAN had already provided invaluable data on its melt from warm currents during its first visit.
But this time,
the submersible just disappeared. No alarm signals, no final pings, no distress calls, just vanished under 500 meters of ice.
any idea what happened?
The precise cause is unknown. Speculation ranges from it getting trapped in a crevasse under the ice, maybe getting stuck in rapidly forming sea ice, or perhaps being swept away by powerful, unexplored subglacial currents down there. We just don't know.
And the data is lost too.
The data it was collecting is lost, yes. The University of Gothenburg team is now urgently trying to secure funding to replace it, because continuing this research is absolutely vital for understanding Thwaites and its contribution to future sea level rise.
It's a sobering reminder, isn't it? How challenging, how unpredictable, how high stakes this kind of exploration really is. And here's where it gets really interesting. These lost missions, these challenges, they reveal just how much we still don't know about these critical, fragile environments.
Absolutely. It underscores the monumental task scientists face in understanding our planet's most extreme regions, even as those regions face increasing threats from climate change.
And tying back to our earlier discussion, those 91 subglacial volcanoes, they also play a role in all this, right? A hidden factor in ice dynamics.
They do. A critical, though often unseen, role. While the volcanic gases might not always punch through kilometers of ice to reach the atmosphere, the geothermal heat they generate certainly does affect the base of the ice sheet.
How so?
That heat is powerful enough to melt vast caverns, create subglacial lakes right at the base of the ice sheet. This process generates significant amounts of meltwater, often trapped under immense pressure down there.
And if I'm understanding correctly, this meltwater doesn't just sit there, it has a critical effect on the ice above it, almost like a hidden accelerator.
Precisely. That meltwater acts as a powerful lubricant. It sits between the colossal ice sheet and the bedrock beneath it.
Like oiling the skids.
Exactly. Imagine a massive block of ice, cubic kilometers in size, sliding on this thin but extensive layer of water. It moves much more easily, much more rapidly than if it were frozen solid to the rock.
So it makes the glaciers flow faster?
It causes the overlying ice to move faster, accelerating the flow of glaciers and ice streams towards the ocean. It's another mechanism directly contributing to sea level rise as more ice gets discharged into the sea.
Is there evidence this has happened before, volcanoes affecting ice sheets?
We have historical precedents, yeah. They offer a glimpse into the potential impact. Mount Takahi, for example, an Antarctic volcano in West Antarctica, had a series of explosive eruptions around 20,000 years ago.
Yeah.
These eruptions released a significant amount of volcanic material, including ozone-depleting chemicals, into the atmosphere. Some scientists hypothesize this release might have led to warming in the southern hemisphere and actually contributed to the abrupt end of the last ice age.
Wow. So a volcanic eruption could help end an ice age.
It's a hypothesis, but it highlights the potential scale of impact. While maybe a single eruption today wouldn't be immediately devastating globally, the potential for a series of eruptions.
Hmm.
From one or more volcanoes located near Antarctica's major ice streams, those fast-moving rivers of ice,
That could be bad.
that could potentially cause devastating and rapid ice loss. It's a scenario that can't be entirely ruled out and is definitely an active area of research and monitoring.
Okay, we've journeyed from debunking myths about pyramids to uncovering these astonishing true wonders under Antarctica's ice, the critical dynamics. But let's zoom out a bit. How do scientists, generally speaking, go about finding hidden wonders, whether it's ancient ruins or buried ice formations or remnants of past climates? What's the sort of archaeological, geological playbook for uncovering the unknown?
That's a great question. It really illustrates the systematic and often very patient approach needed for discovery. Archaeologists, earth scientists, they use several P methods. Sometimes it's serendipity, sometimes pure design,
Like finding things by accident.
sometimes. Firstly, there are what we call development-driven discoveries. Many places have regulations requiring archaeological or geological surveys before new construction begins.
Like before building a new road or shopping mall?
Exactly. Specialists have to inspect the site for artifacts, man-made objects, or ecofacts, things like ancient pollen or animal bones, before the bulldozers move in. This often leads to unexpected, invaluable finds that would otherwise be destroyed.
So the Earth is sometimes forced to give up its secrets just before they're paved over? What about finding places that aren't under threat from development? Truly lost sites?
For those, researchers often dive deep into historical records, channeling their inner Indiana Jones, maybe, but with less whip-cracking and more library time.
Right.
They sift through old documents, maps, explorer journals, colonial records, even transcribed indigenous oral histories, trying to piece together the puzzle of human activity or geological shifts in an area, looking for clues about where to focus their search.
Like finding Petra. Wasn't that partly folklore?
Exactly. The lost city of Petra was rediscovered in the early 19th century, partly thanks to ancient Bedouin folklore and explorer accounts pointing the way. And then, before any serious digging starts, visual scanning and remote sensing are crucial.
Looking for stuff on the surface.
Yeah, archaeologists might use a grid system, systematically walk across the site, looking for anything visible, bits of pottery, stone tools, changes in vegetation, even ancient landfills, which can be treasure troves about past diets and economy.
Landfills as treasure troves. Interesting.
And increasingly, they use tech like LiDAR, that's light detection, and ranging or ground-penetrating radar. These can create detailed maps of subsurface features without breaking ground, revealing outlines of buried walls, roads, anomalies that signal potential finds.
That makes perfect sense. It's systematic. And it reminds me of famous, real archaeological sites that once seemed mythical, hidden, but were eventually found through this kind of diligent work. Sites that show even lost places can be unearthed.
Like Pompeii.
Exactly like Pompeii. Buried suddenly by Vesuvius in 79 AD, frozen in time, then largely forgotten until rediscovered by accident in 1748.
And the preservation.
Yeah.
Incredible.
Absolutely incredible. Entire streets, houses, shops, those plaster casts of people and animals in their final moments, jewelry, vibrant frescoes still on the walls, everyday stuff like bread and wine jars. It's now a UNESCO World Heritage Site. This amazing window into daily Roman life proves that what seems lost can be found, sometimes stunningly preserved.
Pompeii is such a powerful testament to that, to patience, systematic work, and sometimes just sheer luck in discovery.
Yeah.
And it brings us right back to our core theme today, separating myth from material evidence.
Right. Just as we debunked the Antarctic pyramid.
Yeah, there are many other famous mysteries or common misconceptions out there. Fascinating stories, but they don't always hold up to scientific scrutiny or the actual evidence.
Like the idea that you can see the Great Wall of China from space, or even the moon. I definitely remember hearing that as a kid, almost presented as fact.
It's a really popular one, gets repeated all the time, but unfortunately it's just not true.
No, but it's huge.
It is unbelievably long, yes. An absolute breathtaking structure, stretching about 21,000 kilometers, nearly 5 times the distance from New York to L.A. Built over centuries, mostly from rammed earth and wood initially, later reinforced with brick and stone.
So why isn't it visible from space?
While it's immense in length, it's relatively narrow, maybe 4 to 9 meters wide typically. And crucially, its construction materials tend to blend in with the surrounding terrain. From orbital distances, it's just too thin and lacks contrast.
So astronauts can't see it.
Astronauts have confirmed you can barely discern it with the naked eye, even from low Earth orbit, and only under perfect conditions if you know exactly where to look. From the mind, absolutely impossible, utterly invisible.
Huh. So its significance isn't its visibility from space.
Not at all. Its true significance is its millennia-long history as this monumental defensive barrier against northern invasions, a testament to incredible human ambition, engineering, and sheer perseverance over centuries.
Okay, good myth busted. What about the secret chamber in Mount Rushmore? That sounds intriguing. Carved right into the rock behind Lincoln's head, like something out of National Treasure.
Ah, the Hall of Records. That one's actually not a myth, but its purpose and accessibility are often exaggerated.
Oh, really? So it exists.
It does. Gutzon Borglum, the sculptor, did envision this grand Hall of Records inside the mountain, an ambitious plan to carve depictions of America's history for future generations.
Like, did they build it?
Well, the full scope proved too complex during the main construction, but a secret chamber was built behind Abraham Lincoln's head. It was meant to store key historical knowledge for posterity.
What's inside?
It contains 16 porcelain enamel panels, created much later in 1998. They illustrate U.S. history, the Bill of Rights, Borglum's motivations. Construction halted for decades after Borglum died, but this chamber was finally completed in the late 90s.
Can you go inside?
No, it remains inaccessible to the public, sealed away, intended perhaps only to be opened if humanity ever needed to rediscover its past. A time capsule, essentially.
So a real secret chamber, just not one for tours or treasure hunting.
Okay. Now, flipping back to things that look artificial but aren't. What about that famous pyramid on Mars? Another one that sparked alien theories from a NASA photo.
Right, that image from the Mars Reconnaissance Orbiter's high-rise camera maybe a decade or so ago. It did show something that looked remarkably like a three-sided pyramid.
Yeah. So Martians.
Probably not. Just like here on Earth, some immediately jumped to ancient Martian civilizations, but science quickly provided the geological explanation.
Quick was.
This pyramid is located in Candor Chasma, part of Valles Marineris, one of the deepest, most complex canyon systems in the entire solar system. And this specific formation, it's not unique there. The region is full of similar, naturally triangular or pyramidal-shaped landforms.
How did they form? There's natural geology, extensive wind erosion over millions of years, tectonic faulting, mass-wasting landslides, collapses shaping the Martian bedrock into these distinct angular features. Geologists analyze the terrain, the rock composition, compare it to known processes. It's confidently concluded to be natural.
Just extraordinary Martian geology. No aliens needed.
Exactly.
Okay.
Sometimes the natural explanation is just as cool, if maybe less fantastical.
True. Okay, one last one in this vein. Those ancient Egyptian tomb traps we see in movies. Poisonous scorpions falling from the ceiling, giant rolling boulders, collapsing floors, pits of snakes, all designed to take out intruders. Did those actually exist? Were pharaohs really engineering deadly booby traps?
Hollywood definitely loves to dramatize tomb protection, doesn't it? Scorpions, snakes, crushing boulders. It makes for great cinema.
But not accurate.
The reality was far more subtle, maybe more ingenious, and probably more focused on simple deterrence and confusion rather than elaborate killing machines. Ancient Egyptians and other cultures like the Maya certainly built massive monuments to protect their elite dead and their wealth.
So what were the actual traps like?
Technologically simpler. Things like building empty rooms inside the tomb to mislead intruders, make them think they'd reached the end or that it had already been looted, creating false passages, dead-end shafts to waste a robber's time and resources, maybe make them give up.
Ah, psychological warfare almost.
In a way. Take the tomb of Pharaoh Amenhotep II in Luxor. Massive structure, over 10 chambers. But the king's actual burial chamber is the most hidden one. Robbers would have to navigate all these empty spaces first, potentially getting frustrated thinking there was nothing valuable left.
Lever.
Other tactics included false entrances, or placing the real burial chamber deep down in an unexpected location, making it incredibly hard to find. The real threat to ancient Egyptian tombs wasn't giant boulders, it was persistent, clever thieves. People who might dig secret tunnels for months or even bribe the tomb workers themselves to reveal secrets.
So the best trap was just making it really hard and time-consuming.
Exactly. The sheer scale and complexity of the burial site was often the main deterrent, making detection and penetration incredibly difficult, time-consuming, increasing the risk the robbers would simply be caught by guards or authorities rather than falling victim to some elaborate physical mechanism.
That's a much more grounded, maybe more terrifying reality for ancient tomb raiders. Not a quick death by boulder, but months of fruitless labor and the constant threat of capture.
Okay, now from secrets buried shallowly or revealed by melting ice, let's dive really deep, right into the deepest mysteries of our planet itself, connecting our Antarctic explorations to the very core of the Earth.
The Earth's core. Okay.
We generally learn Earth has several distinct layers, right? The crust we live on, the massive mantle, the liquid outer core, and the solid inner core.
Right, the standard model.
But recently, a truly remarkable discovery has added a new wrinkle, a new dimension. Scientists have identified evidence for a fifth layer, hidden within the solid inner core itself.
A fifth layer. Inside the inner core. That's astounding. The inner core alone is, what, 2/3 the size of the moon? And incredibly hot, like 500 degrees Celsius, same as the sun's surface.
That's right. Studying something so deep, so hot, under such immense pressure, it's incredibly challenging. We can't even begin to drill there.
So how did they find this fifth layer?
Indirect methods are key. Lab experiments replicating the pressure and temperature, complex computer models, and crucially, analyzing seismic waves from earthquakes.
Ah, using earthquakes like a planetary ultrasound.
Exactly. During an earthquake, you get P waves, primary compressional waves, and S waves, secondary shear waves. They travel through Earth's interior at different speeds along different paths, depending on the material they pass through.
And they change as they go through different layers.
Precisely. Scientists collect data from tens of thousands of deep earthquakes, some starting over 100 kilometers down. They track how these waves shift, reflect, refract as they travel right through the planet to seismic stations on the other side.
And that revealed the fifth layer.
It was through analyzing subtle changes, particularly in the travel times and characteristics of P waves as they pass through the inner core from different angles, that this previously unknown fifth layer, or distinct region within the inner core, was inferred.
What's different about it?
It seems seismic waves travel fastest through the inner core, roughly parallel to the Earth's rotation axis, north to south, but slightly slower along the equator. This difference suggests a distinct structure within the very center, maybe a different alignment of the iron-nickel crystals, or a slightly different composition. Still debated, but it points to more complexity.
So the Earth's internal structure is even more complex, more dynamic than we thought, right down to its very heart. What's the critical role of these deep layers, especially the core, for life up here on the surface? What does it actually do for us?
Oh, the core is incredibly important, especially the spinning, molten outer core. This liquid metal layer, mostly iron and nickel, acts like a gigantic dynamo,
Generating electricity.
generating Earth's powerful magnetic field. Its convection currents, driven by heat escaping the solid inner core and Earth's rotation, create this field. And it's our planet's primary shield.
Shielding us from what?
It extends thousands of kilometers out into space, protecting us from dangerous solar wind, those streams of highly charged particles the sun constantly emits. Without that magnetic field, the solar wind could strip away our atmosphere over time, like what probably happened to Mars. Life as we know it would be impossible on the surface without it.
Wow, so it's literally a lifesaver.
Absolutely. And it's also fascinating to think about how the Earth might breathe or pulse. Remember that regular 26-second pulse scientists discovered in the 90s?
Vaguely, yeah. The Earth's heartbeat.
Kind of. The tremors are tiny, imperceptible mostly. One leading idea is that the continental shelves, those underwater extensions of continents, might act as seismic breakwaters. Waves hitting these steep slopes could produce this regular resonant pulse that then travels across the whole planet. Still an area of active research, but it paints this picture of a planet constantly in motion inside and out.
That's truly mind-boggling. Our planet having a consistent heartbeat may be created by its own geography. Okay, let's play that thought-provoking what-if game. What if somehow the Earth's core cooled down, stopped spinning, stopped generating that vital magnetic field? What happens to us?
The implications. They'd be nothing short of catastrophic. It would transform our planet beyond recognition.
How so?
First, with all the heat from the core driving convection in the mantle, you'd lose plate tectonics.
So no more earthquakes or volcanoes.
Exactly. No more movement of continents. And while fewer earthquakes might sound good, losing volcanic activity is bad. Volcanoes replenish fertile soil with minerals, release gases like CO2 that help regulate temperature and form the atmosphere.
Without them.
Dwindling resources in fertile lands, a gradual shift in atmosphere composition.
Okay, that's bad. What else? The magnetic field loss.
That's perhaps even more devastating. Losing the magnetic shield exposes us directly to intense solar and cosmic radiation.
What would that do?
It would wreak havoc on electrical grids, knock out satellites, disrupt all communications. Life on the surface would become incredibly hazardous due to radiation exposure. Cities might need heavy shielding, maybe humanity forced underground.
Underground cities.
Possibly. Plant and animal life would suffer immensely from DNA damage, leading to mass extinctions. And over the long term, maybe centuries, without the magnetic field protecting it, the solar wind would gradually strip away our atmosphere, blow it away into space.
Turning Earth into Mars.
Eventually turning Earth into a barren, Mars-like wasteland, incapable of supporting complex life. It really underscores how profoundly reliant we are on these deep, unseen processes within our planet.
It's chilling to consider how interconnected everything is, from the hidden core to life on the surface. What a delicate, awe-inspiring balance. Wow, what an incredible journey we've been on today. We started by looking at and pretty much debunking those sensational claims. Pyramids in Antarctica, secret doors.
Nature's illusions, mostly.
Right, revealed as nature's dramatic geological sculptures. Illusions created by ice, wind, rock, and our own pattern-seeping brains. But in doing that, we uncovered realities far more extraordinary.
The real science.
The vast, hidden volcanic regions under the ice. Those ancient climate secrets locked away in ice cores, actual time capsules of past atmospheres. The bizarre blood falls, hinting at prehistoric life, maybe with implications for finding life beyond Earth.
And that rainforest.
And the truly shocking discovery of an ancient rainforest that once thrived near the South Pole. Just amazing.
And we didn't stop there. We delved into the cutting-edge science of exploring under the ice with autonomous vehicles like RAN, mapping unseen landscapes, delivering alarming data about ice melt and sea level rise.
A mission that, tragically, claimed RAN itself.
A real loss for science. We also connected these Antarctic insights to broader methods, how scientists actually uncover hidden knowledge, separating myth from evidence worldwide, from the Great Wall's non-visibility from space to the subtle realities of Egyptian tomb traps.
And finally, we plunge right down into the Earth's core, understanding its layers, its vital magnetic shield, and contemplating that catastrophic what-if of it cooling down, showing just how much we depend on its hidden power.
It's just profound, isn't it? Our dependency on these vast, unseen planetary systems.
It really is. And it's such a powerful reminder that while the fantastical captures our imagination, understanding our planet's natural, often truly awe-inspiring processes, that's far more extraordinary, far more impactful than any fictional narrative. The real wonders are all around us, sometimes deep beneath us, just waiting.
Waiting patiently to be discovered and understood. Absolutely. And the value of continuous exploration driven by rigorous science, critical thinking, it just can't be overstated, especially now in a world flooded with information and misinformation.
Keep questioning.
Keep questioning. There's always more to learn. And considering multiple perspectives while always grounding ourselves firmly in the evidence, that only enriches our understanding of this complex, dynamic, and genuinely miraculous planet we live on.
Well said. We really hope this deep dive has sparked your curiosity even further. Thank you so much for joining us on this incredible deep dive.
Thank you.
Until next time, stay curious. And be sure to check out our previous deep dives for other fascinating journeys, and keep an eye out for what we'll explore next.